Okay, Assalamualaikum warahmatullahi wabarakatuh and good morning. This will be our last class. Okay, so I will discuss on the deep foundation. Okay, and the section set previously. If on the shallow foundations, it is written in section 6. Okay. Okay, in the discussions on the pile foundation, okay, so in section 7, okay, they have stated a discussion on pile load test, okay. So for example, if uh, the consultant has asked for the contractor to uh, conduct a pilot test. Okay, so the consultant can use the result from the pilot test, okay, to determine what is the capacity of the pile, okay, because it is tested on the field or on under full scale test, okay. Then we may discuss on the axial loaded pile. Okay. On this discussion, it's more related to the calculations on to determine the bearing capacity. Okay. So the discussion on the section 7 on vertical displacement of the pile, which is related to the serviceability of the supported structure. Okay, and then there are discussion on the transversely loaded pile, structural design of pile in the same section. Okay. Okay. So consideration taken, okay, need to take into account the action due to the ground displacement, okay, where there are some situations, okay, which is happen under the negative skin frictions. So heave and transverse loading. Okay. So the design value of the strength and stiffness of the moving ground should usually be upper value. Okay. So the ground displacement is treated as an action and interaction analysis is carried out. Okay. Or an upper bound of the force transmitted by the ground is introduced at the design actions. Okay. So, however, in our discussion, okay, we will not discuss on this effect. Okay, we only concentrate on how to determine the capacity of the pile due to the end bearing and also due to the skin frictions. Okay. So okay, in general, in section 7, okay, the design should be based on the one of the following approaches. Okay, the result of static load test, which has been demonstrated, okay, by means of calculations or otherwise, to be consistent with other relevant experience. Okay, so we can use the result from the maintain or the static load test. Okay, either use the average or we can use the minimum value, okay, to be considered as a part of the value for the bearing capacity. Okay, empirical or analytical calculations method whose validity has been demonstrated by static load test in comparable situations. Okay, so in some situation, okay, where we have the maintain load test and also we do a calculation, okay, using the empirical or using the formula, okay. So it also could be applied, okay. The result of dynamic load test whose validity has been estimated by static load test is comparable situation, okay. So then there will be another methods, okay, they call as a dynamic load test or pi dynamic analysis, PDA, okay, could also be used, okay. The observed performance of comparable pi foundation provide that this approach is supported by the result of site investigation and ground testing. Okay. So for the pilot test shall be carried out in the following situation, okay, when using a type of pile or installation method for which there is no comparable experience, okay, when the pile has not been tested under comparable soil and loading condition, when the pile will be subjected to loading for which theory and experience do not provide sufficient confidence in the design, okay, the pile testing procedure should then provide loading similar to the anticipated loading. Okay, when observation during the process of installation indicate pile behavior that deviates strongly and unfavorably from the behavior anticipated on the basis of the site investigation or experience, and when additional ground investigation do not clarify the reason for this deviation. Okay, so it will be more uh, convincing, okay, if we are using the pilot test result. Okay, so I'm not pretty sure, okay, uh, for one site, how many pilot tests should be carried out. Okay, it depends on the first on the budget, okay, and second, uh, and how many piles that has been installed. Okay, for example, perhaps 10 pile should be present by one maintain load test. Okay, so my experience, okay, I have seen the procedure for the PDA, okay, what we call it, pile dynamic analysis, okay, and also for the maintain load test, okay, uh, and definitely the cost for the maintain load test is very expensive, okay, it can reach up to 300,000 per one testing, okay, so that's why it's very costly, okay, if uh, we want to have a lot of what we call as a maintain load test compared to the PDA. Okay. However, in the section 7, okay, so looks like it is a part the pilot test can be used as a part of the justification to determine the bearing capacity value. Okay. So for the loading procedure, okay, the pilot test procedure, particularly with respect to the number of loading steps, the duration of this step, and the application of loading cycle, shall be such that conclusions can be drawn about the deformation behavior, creep, and rebound of the pile foundation from the measurement of the pile. Okay, for trial piles, the loading shall be such that conclusion can also be drawn about the ultimate failure loads. Okay, so pilot test for the purpose of designing a tensile pile foundation should be carried out to failure. Extrapolation of the load displacement graph for tension should not be used. Okay, so normally in the design, okay, so in the pilot test, okay, they will test until, for example, 2 times working loads. Okay, so then they measure as well what we call as the settlement. Okay, so the settlement for the working load, okay, shall around or no more than 12.5 millimeter, okay, in order to cater for the serviceability limit state. Okay, so then for the twice a working load, okay, the value of the settlement should not more than 38 millimeter. Okay, so that is the value that should be obtained, okay, for the settlement under the twice working loads. Okay, so definition of the failure loads on pile. Okay, generally failure is taken as the load causing ultimate failure of a pile. Okay, in engineering sense, failure may have occurred long before reading the ultimate load, since the settlement of the structure will have exceeded the tolerable limits. Okay, so the tolerable limit, which I have mentioned previously, okay, which is 12.5 for the working load and 38 millimeter for the uh, twice working loads. Okay. So although it can cater up to a certain load, but we need to make sure that the pile is not exceed the tolerable limit. Allowable load on the pile would be one which would enable engineer to predict load settlement relationship up to the point of failure for any given type of pile in any soil or rock conditions. Okay. In most cases, the procedure is to calculate the ultimate bearing of the isolated pile and to divide this value by a safety factor, which experience has shown will limit the settlement and the working load to a value which is tolerable to the structure designer. Okay. So the design of the pile should comply with the following requirement throughout their service life. Okay, there should be adequate safety against ultimate limit state failure of the ground. Okay, the FOS depends on the importance of the structure, consequence of the failure, credibility and adequacy of information on ground condition, sensitivity of the structure, nature of the loading, local experience, design methodologies, number of representative preliminary pile load tests. Okay. There should be adequate margin against excessive pile movement, which would impair the ultimate serviceability limit of the structure. Okay. So these two items, okay, should be considered, okay, to prevent for the from the pile uh, reach the failure, okay, and also to make sure that the pile could provide a good service during the service life. Okay. So pile analysis based from EC7. Okay. So we go first for under the what we call the direct methods. Okay. So the same procedure with the shallow foundation. Okay. For axial loaded pile and anchor. Okay. So then we have a combinations of number one. Okay. A1 plus M1 plus R1. Okay. And then we have a combination number two, okay, which is A1 plus M1 or M2, and then plus R4. Okay, the R4 little bit different with the shallow foundation. Okay, where the shallow foundation they use the R1. Okay, where M2 is for calculating any unfavorable action such as negative skin or transverse loads. So it depends. Uh, uh, either we should get based on the condition of the soil. Okay, so we need to look at the it behave it have a negative skin effect. It's negative skin friction effect. Okay. 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 Okay, this is the table. Okay, so we have a combination number one and combination number two. Okay, so and also it depends on the type of the installations. Okay, so we have a driven pile, bore pile, CFA. Okay, this is continuous flight auger. So like a drill. So they have an auger, okay. So the installation is different between driven and bore pile, okay. So for example, a driven pile, they use a hammer, okay. So then bore pile, they create a hole, and then they install all the cage and pour the concrete, okay. And the CFA, okay, they use an auger system like a drill. So then they drill the CFA pile inside the soil. Okay. So and there will be a different in terms of the R4 value. Okay. So for the R4 value, okay, if we consider the service limit state calculation, so we use the R4 on this column. Okay. Okay. And then if we are using the if we are not consider the SLS, so then we may refer to the R4 on the second last columns. Okay. So M2 uh, is similar like a shallow foundation. Okay. So for example, if it's construct on the slope and embankment, so we use the M2 on this column. Is far from the slope and embankment, so we use this M2 in these columns. Okay. So the rest uh, for the value of, for example, of for the soil. Okay. So there is no a difference between the shallow and also on the deep foundations. Okay. So recommended value for partial factor safety under negative skin friction. Okay. So there we have a permanent structural action. Okay. So negative skin friction value and comprehensive resistance. Okay. Positive skin. Okay. So this guide recommended that this M2 value is applied as a partial action factor, not a material factor, because the negative skin friction is usually estimated without recourse to the angle of shearing resistance of the ground. Okay, so on the what we call it, on the M1 and M2, okay, so the value is 1.25. Okay. So it is related to the shear strength of the soil. Okay, effective cohesion. Okay, but I will not touch on this skin friction effect. Okay, um, because we only focus on the normal condition of the pi calculations. Okay, okay. So this is the general equation for the axial loaded single pile. Okay, so there we have RD, which is QB over gamma B plus QS over gamma S. Okay, so or we can use the QB plus QS over gamma T, which is referred to the total partial factors of safety. Okay. So then a comparison should be made, okay, in terms of the RD and also the Q value. Okay. So this is almost the procedure is almost similar with the shallow foundations. Okay. Okay. So the same procedure uh, with the shallow foundation. Okay. For the undrained, okay, we refer to the clay. Okay, while for the drain we refer to the what we call as to the sand. Okay, so for pile in undrained condition, okay, where phi is equal to 0, so QB is equal to AP times SC and CCU plus sigma Q. Okay, so to gain the NC value, okay, we may refer to the chart, okay, this chart, okay, to determine the NC value. Okay. So however for LD, L over D greater than 5, okay, so SC and C, okay, is less than 9, okay, based from the scantum, those giving QB, AQP is equal to 9 CuAp. Okay. So all the soil above the base value is treated as a charge where sigma Q is equal to sigma V at the level of the pile base. Circular pile are treated the same way as a square pile for shape factor SC. Okay. So we may discuss in detail by looking at the example later. Okay. So the value of the MC depends on the type of the what we call of the pile. Okay, either it's square or strip type. Okay. So different case of soil layer. Okay. So this is an additional what we call as approach. Okay, where if we have a different or we have a multi-layer of soil. Okay, it is possible to utilize various conditions to account for soil surrounding the pile as shown. Okay, for case A and B, the value of NC and SC is limited to SC and C equal 9. Okay, and can be found from the previous scan term calculation. Okay, wait a minute. So for the case C, okay, this one, SC and SC is to be taken from after. Okay, so for the case D and E, okay, then use this formula. Okay, APSC times 2 plus Phi Cu plus CB over 4 FZ plus AP sigma Q. Okay, where SC is equal 1.2 and FZ as figure shown after. Okay, so we look how they define the FZ and also the SC as well. Okay, for the case C. Okay, sorry. Okay, so this is for the case C to determine the NC under a different layer of soil. Okay, so then we have the NC, then SC. Okay, then for the case D and E, okay, so we use the term of FZ, okay, to estimate the end bearing value. Okay, so that is for the drain condition, undrained condition, which is represent the clay. Okay, so this is for the drain condition. Okay, so in drain soil, base resistance can be simplified into QBU equal to AP NQ sigma prime Q. Okay, so the value of the NQ is given by, okay, so this is the value of the NQ. Okay, we can directly use this formula. Okay, or we can use this chart to gain the value for the NQ. Okay, so it depends on the ratio between the LP over D naught. Okay, so value given by Verizon for circular pie should therefore use the solid line as shown as figure shown. Okay, so we have two what we call as two lines here. Okay, where the solid line represent the Verizon and the dash line is the value from these equations. Okay, so the value of NC implicitly include the effect of shape. Okay. Okay. So that is for the end bearing. Okay. We may look later on some example to determine the bearing capacity based on the drain and also drain. Okay. For the skin resistant in undrained soil, okay, three methods normally adopted, okay, which is alpha, lambda and beta methods. Okay, so for the alpha should be limited to 150 kilonewton per meter square. Okay, so hello,
Hello, doctor.
yeah,
Sorry for taking you back. The chart you show us just now for the value of NQ. In the chart, I saw if the ratio of L over D is equals to 5.
yes.
Now, does it indicate that if the value is 5 and above, we can use the chart, or if it is below 5? Because I don't really understand that one. If you don't mind, you can clarify my doubt, please.
Okay, for this part,
Yes,
okay,
doctor.
okay, okay. L is the length, D is the diameter. Okay, so normally to represent a what we call as a deep foundation. Okay, so the ratio of L or D should greater than 5. So if less than 5, normally we consider as a shallow foundation. Ojo?
Okay, thank you, doctor.
Ah. So for the what we call as for the ratio of LLD is for the deep foundation, it should greater than 5. Okay.
Okay,
Okay.
thank you, doctor.
You're welcome. Okay. So then we have alpha methods. Okay. Alpha times SU. Okay. Where it depends on the what we call as on the undrained shear strength of the soil. Okay. So it is a very soft value which is less than 25. So we use the alpha 1. Okay. So it's range of 25 uh, to 75. Okay, so it should use the second equation of the alpha, and then for the alpha which is greater than 75. Okay, so we use the 0.5. Okay. Hmm. Okay. Okay, so okay, this is the chart to determine what we call as the alpha value addition factor. Okay, so we can use this chart rather than we use this kind of what we call as uh, statement. Okay, so then there also this addition factor. Okay, similar like this one. Okay, so this is for a drill shaft. Okay, uh, so most probably it is referred to the what we call as CFA type. Okay, so then we have a lambda, the last one. Okay, so the lambda we can determine the value based on this diagram. Okay, okay. So we may use the equation later on from the example. Okay, so this is just to introduce the methods to determine the skin friction value. Okay, so then we have a beta. Okay, this is for the beta. Okay, while this is the formula. Okay, so it depends on the type. Either it's normally consolidated or over consolidated. So this is the this is the chart that could be used, okay, to for the beta methods, okay. So this is much more easy compared to use to estimate uh, the value for the beta under a different OCR and also different fee value. Okay. Okay, so this is beta as well under the Frillenius approach. Okay, for normally consolidated seed and clay, beta is around 0.27 and 0.5. Okay, for heavily over consolidated clay, beta should be much higher. Okay, so if we doesn't have any value to get for the over consolidated clay, okay, so it's better for us to use the previous one or use this value to determine the beta. Okay, so that is for the undrained. Okay, now for the skin resistant in drain condition. Okay, so then we use this formula. Okay, so then they are K value. Okay, this K value it depends on the type of the pile installation. Okay, so for example for bow pile, so this is the K that we may use. It depends on the fee value. Okay, so for the driven pile, so it depends on how the method of the installation, which is if it's a low displacement, so we use this K value. Okay, so if it's high displacement, so we should switch to the this value. Okay, so it may depend on the what we call as on the descriptions. Okay, during the on description on the installation to consider either is low or high. Okay, so Fs will be constant at a conservative estimate of 15D. Okay, so the sigma V, okay, uh, will depends on the what we call as on the depth up to 15D. Okay, so this 15D, okay, um, we should count, okay, because we doesn't want to overestimate the friction from the skin of the pile. Okay, let's say the diameter of the pile is 1 meter. Okay, so the depth, effective depth is 15 times 1, 15 meter. So the effective stress only consider up to 15 meter, and then it will constant uh, value downward. Okay, so let me show you. Okay, so okay, so for example, this is the depth profile. Okay, so then when we calculate for the 15D, okay, so this is the effective vertical stress. Okay, so normally yeah, typically it will increase with a depth. Okay, however, when we use the 15D, okay, so means that when it reach the 15D, so it will have a constant value, okay, up to the length of the pile. Okay, for example, if the pile is 30 meter, okay, and the D is the 15D is 15 meter. So the rest for calculation for the skin friction, okay, should be consistent in term of the effective stress value. Okay, so means that starting from here to the end of the pile, okay, the sigma V is same, okay, starting from the 15 meter from the pile depth. Okay. So the alpha method is used to estimate the short-term pile load capacity in fine-grained soil. Okay. The beta method is used to estimate the short-term and long-term pile capacity in coarse-grained soil and long-term pile capacity in fine-grained soil. Okay. The actual value for the alpha, beta, and NQ is uncertain. Okay. So the limiting value given are not theoretical limit but are based on experience on certain soil deposit. They do not pertain to all situations. Okay. So due to the difficulty in obtaining accurate value of the required parameter, okay, so empirical correlation based on the result of the pile loading in situ test are commonly used to provide alternative solution. Okay, so this is the drawback from the what we call it from the empirical from this formula. Okay, so it's better to use the in situ or a loading test, okay, to estimate the pile capacity. Okay, so for example, for the empirical test, okay, we may use the SPT value, okay, to estimate the capacity for the end bearing and also for the skin friction. Okay, so this is the formula. Okay, because normally, um, when we yeah, normally we may conduct for the soil investigation work. Okay, so in the soil investigation work, okay, normally we use what we call as the SPT value. Okay, or we carry out the SPT. Okay, so it will be a straightforward, okay, when we use the SPT, okay, in determine the value um, for this ultimate uh, failure for the pile capacity. Okay, then for the shaft, we also can use the what we call as the SPT, okay, corrected N60. Okay, so by applying this what we call using this formula, then we can estimate the US for the skin friction. Okay, so that is for the SPT. Okay, so another option by using the CPT. Okay, so for the CPT, we can determine the end bearing and also uh, for the end bearing only. Okay, for the shaft resistance CPT give unrealistic value. Those other method will be suggested. Okay, so CPT is not very typical to be used. Okay, rather than the SPT. So in this case, it's better to use the SPT. Okay, to estimate what we call as the capacity of the pile. Okay, okay. Okay, so CB. Okay, this is the CPT. CB. Okay, this is based on the CPT. Okay, so from this is from the CPT, while this is from the SPT. Okay, for the CB. Okay, this is CB. CB from the SPT. Okay, while for the CS, used to. Okay, so this is the value of the CBN CCPT. Okay. So another approach by using the ultimate limit state from the load test. Okay, so the ultimate capacitive resistance from the static load test. Okay, we can use this value. Okay, so for structure which do not exhibit capacity to transfer load from weak pile to strong pile as the minimum, the following equation should be satisfied. Okay, so either we use the average value and then we compare with the minimum value. Okay, so it depends on how many testing that has been carried out by using the load test. Okay, so this is zeta value. So in the EC7, okay, they provide a zeta value, okay, as the partial factor safety value for the load test. Okay. So for the verification for structure and geotechnical limit state, the following correlation factor, which is zeta, should be applied to derive the characteristic resistance of axial loaded pile. Okay. So zeta 1 on the means value for the measure resistance in static load test. Okay. So zeta 2 is the minimum value of the measure resistance in the static load test. Okay, zeta 3 on the mean value of the calculated resistance from the ground test result. Okay. So zeta 4 on the minimum value of the calculated resistance from ground test result. Okay, so they are different. For the static load test, we are using this zeta 1 and also zeta 2. Okay. So zeta 3 and zeta 4 is more related to the result from the SPT, while zeta 5, zeta 6 is related from the PDA of any dynamic load test. Okay, so what is the value of the zeta? So we may look on this um, table. Okay, so for example, for the static load test, okay, so if we have a number of testing equal to 2, okay, so we get the average and then we divide with the 1.3. Okay, okay, for the mean, okay, we find what is the minimum value and then we divide with 1.2. Okay, so it's more than 1, so the confidence level is decrease is reach 100%. Okay, because before this we just only use 1, so we need to divide to 1.4. Okay, so means that when it's greater than 1, so we use the absolute value from the static load test for the mean and also for the for the minimum. Okay, so because the static load test is the full scale test that we carry out in the in the field, and it's very costly. Okay, so on the ground test, okay, by using the SPT value or CPT, then we use this partial factor safety. Okay, so we need to run up to 10. Okay, and then yeah, we have a choice to run up to 10. Okay, to in order to decrease the value of the zeta. Okay, so for the dynamic impact test, okay, so it depends on how many tests. The minimum is 2. Okay, so then it can more than 20. Okay, so that is for the factor of zeta under the in situ or full scale test. Okay. So then we have another value to be considered, which is the model factor. Okay, may be applied to the design value of resistance or effect of an action to ensure that the result of the design calculation model are either accurate or on the safe side. Okay, so after we apply the what we call a partial factor safety, then we apply another one is the model factor. Okay, so means that we want to have a very safe pie design. Okay, so model factor required in the pie design are provided in the section 1A3 3.3.3.2. Okay, so normally the value for the model factor, okay, from 1.2 to 1.4. Okay. So for example, without any what we call it, any verification from the maintain load test, we use 1.4. Okay. So this is based on the experience calculation. Okay. But when we carry out for the maintain load test, then we divide with 1.2. Okay. So this is to means that the confidence level has been increased or the model factor has been reduced. Okay. Okay. So then we have a pile groups. Okay. So for pile in group, two failure mechanism should be taken into account. Okay. Compressive resistance failure of the pile individually. Okay. Then we should consider as a group. So acting as a block. So we should compare based on the design under individual, and then we multiply the number of the pile, and we should consider as a group of pile where the failure is acting as a block. Okay, the design system should be taken as the lower value caused by these two mechanisms. Okay. So then pile intention for pile two failure mechanism should be considered pull out of the pile from the ground mass, uplift of the block of the ground containing the pile. Okay, so this is situation for the pile in tension. Okay. So as a conclusion, okay, designing pile foundation with Eurocode 7 important of static load test. Okay. So if we carry out the static load test, the what we call as uh, the the confidence level getting high. Okay. So an innovative approach to pile capacity taking account of number of load tests or number of soil profile. Okay, need of assessing serviceability of structure through displacement calculation. Okay. So however, for this subject, okay, I will not include the settlement calculation for the pile. Most probably I will introduce on the next following semester. Okay. Okay, so that is for my slide presentation. Okay, we take a rest. Okay, before we move to the example. Okay, so 5 minute rest, then we move for the example.